What if I told you that the moon, the glowing companion we see every night, is not as unchanging as it seems? Picture this, a celestial body that's been silently shaping our planet for billions of years, yet it's slowly slipping away from us. That's right, our moon is drifting farther into space, and that's just the beginning of its secrets. Today, we're diving into 20 mind-blowing facts about the moon that will completely change how you see our closest cosmic neighbor. From its mysterious dark side to its potential as a future home for humanity, these facts will leave you in awe. So, buckle up and get ready to explore the moon like never before. By the end of this video, you'll see that glowing orb in the sky as more than just a pretty face. It's a world of wonder waiting to be discovered. Let's get started. Now let's zoom in on the first mind-blowing fact. The moon is drifting away from Earth. Yes, our lunar companion isn't staying put, it's slowly moving farther into space at a rate of about 3.8 centimeters every year. This might not sound like much, but over millions of years it adds up. Scientists believe this drift began billions of years ago when the moon was much closer to Earth, and it's been inching away ever since. So, what's causing this cosmic retreat? It all comes down to gravity and the tides. The moon's gravitational pull creates the ocean tides on Earth, but Earth's gravity also tugs back on the moon. This gravitational tug-of-war transfers energy, causing the moon to gradually spiral outward. But here's where it gets even more fascinating. This drift isn't just a one-way street. As the moon moves away, it's also slowing down Earth's rotation. Over time, this means our days are getting longer by about 2 milliseconds every century. Imagine that in the distant future, Earth's days could stretch to 25 hours or more. And let's not forget the impact on tides. As the moon drifts farther, its gravitational pull weakens, which could lead to smaller tides. This might not seem like a big deal now, but it could have profound effects on marine ecosystems and coastal environments over millions of years. To put this into perspective, let's rewind the clock. Around 4.5 billion years ago, the moon was likely just 15,000 miles away from Earth compared to the 238,000 miles it is today. Back then, the moon would have appeared massive in the sky, and Earth's days were only about 5 hours long. So, while the moon's drift might seem slow and subtle, it's a reminder of how dynamic our solar system truly is. Every year, that 3.8 centimeters adds up, shaping the future of both Earth and its lunar partner. And who knows, in billions of years, the moon might be so far away that total solar eclipses where the moon perfectly blocks the sun will become a thing of the past. This is just the beginning of the moon's incredible story. Next up, we'll explore another fascinating phenomenon, moonquakes. Stay tuned. Now, shifting our focus to another astonishing lunar phenomenon, let's talk about moonquakes. Yes, just like Earth has earthquakes, the moon experiences its own version of seismic activity. But here's the twist, moonquakes are quite different from what we experience here on Earth. For starters, moonquakes can last much longer, sometimes up to 10 minutes or more. On Earth, earthquakes typically last only a few seconds or minutes. This extended duration is due to the moon's lack of water and atmosphere, which means there's nothing to dampen the vibrations. The moon's surface is essentially a giant echo chamber, allowing seismic waves to reverberate for much longer periods. So, what causes these moonquakes? There are a few key factors. One major cause is tidal forces. Just as the moon's gravity pulls on Earth's oceans, Earth's gravity tugs on the moon, creating stress in its crust. Over time, this stress builds up and is released in the form of moonquakes. Another cause is meteorite impacts. When space rocks collide with the moon, they generate shock waves that can trigger seismic activity. Interestingly, moonquakes were first discovered during NASA Apollo missions. Between 1969 and 1972, astronauts placed seismometers on the moon's surface to measure its internal activity. These instruments recorded thousands of moonquakes, revealing that the moon is far more geologically active than we once thought. There are even different types of moonquakes. Some occur deep within the moon's interior, while others happen closer to the surface. The deepest ones, known as deep moonquakes, are thought to be caused by the same tidal forces that shape Earth's oceans. Meanwhile, shallow moonquakes, which are less frequent but more powerful, remain a bit of a mystery. Scientists believe they might be linked to the moon's cooling and shrinking over time. What's truly fascinating is how these moonquakes could impact future lunar exploration. Understanding their patterns and causes is crucial for building safe and stable structures on the moon, especially as we look toward establishing permanent bases or even colonies. So, while the moon might seem like a silent, unchanging world, it's actually alive with seismic activity. And as we continue to study these moonquakes, we uncover more secrets about our celestial neighbor. Up next, we'll explore another intriguing lunar mystery, the so-called dark side of the moon. Stay tuned. Now, let's shed some light on one of the most misunderstood aspects of the moon, the so-called dark side. Despite its name, the dark side of the moon isn't actually dark all the time. In fact, it receives just as much sunlight as the side we see from Earth. The real reason we never see it is due to a fascinating phenomenon called tidal locking. Tidal locking occurs because the moon's rotation period, the time it takes to spin once on its axis, is exactly the same as its orbital period, the time it takes to complete one trip around Earth. This means the moon always shows the same face to us, while the other side remains hidden from view. Think of it like a dancer spinning in place while always keeping one hand pointed toward their partner. But here's the kicker: the far side of the moon isn't shrouded in perpetual darkness. It experiences the same cycle of day and night as the near side, with each lunar day lasting about 2 Earth weeks. During its day, the far side is bathed in sunlight, and during its night, it's plunged into darkness just like the side we're familiar with. This misconception likely stems from the fact that the far side was completely unknown to humanity until the mid-20th century. It wasn't until 1959, when the Soviet spacecraft Luna 3 captured the first images of the far side, that we got a glimpse of this mysterious region. Since then, missions like NAS, a lunar reconnaissance orbiter, have provided even more detailed views, revealing a landscape that's strikingly different from the near side. The far side is marked by fewer of the large, dark plains called Maria that dominate the near side. Instead, it's covered in rugged highlands and countless craters, making it a treasure trove for scientists studying the moon's geological history. Understanding tidal locking and the true nature of the moon's far side is crucial as we plan for future exploration. Whether we're setting up telescopes to peer into the depths of space or building habitats for lunar colonies, knowing how the moon's rotation and orbit work will help us make the most of this incredible celestial body. Up next, we'll dive into another lunar mystery, the moon's lack of atmosphere and what that means for life and exploration. Stay with us as we uncover more mind-blowing facts about our closest cosmic companion. Now, shifting our focus to another fascinating aspect of the moon, let's explore what it means for a celestial body to have no atmosphere. Unlike Earth, which is wrapped in a protective blanket of gases, the moon is completely devoid of an atmosphere. This absence has profound effects on its environment and poses unique challenges for exploration. Without an atmosphere, the moon experiences extreme temperature swings. During the lunar day, temperatures can soar to a scorching 127 degrees Celsius, hot enough to boil water. But when night falls, they plummet to a bone-chilling minus 173 degrees Celsius. These drastic changes occur because there's no atmosphere to trap heat or distribute it evenly across the surface. On Earth, our atmosphere acts like a giant thermostat, moderating temperatures and creating weather patterns. It shields us from harmful solar radiation and provides the air we breathe. But on the Moon, the lack of an atmosphere means no weather, no clouds, and no protection from the sun's intense rays or the vacuum of space. This harsh environment has significant implications for lunar exploration. Astronauts and equipment must be designed to withstand these extreme conditions. Spacesuits, for example, are equipped with advanced insulation and cooling systems to protect against both the searing heat and the freezing cold. Similarly, lunar rovers and habitats need to be built with materials that can endure these temperature extremes without failing. Another challenge is the absence of air. Without an atmosphere, sound cannot travel, making the Moon eerily silent. This also means there's no oxygen to breathe, requiring astronauts to carry their own life support systems. Additionally, the lack of atmospheric pressure makes it impossible for liquids to exist in their natural state, which affects everything from drinking water to fuel storage. Despite these challenges, the Moon's lack of atmosphere also offers unique opportunities. For instance, the absence of air and weather makes it an ideal location for astronomical observations. Telescopes placed on the Moon could capture clearer images of the universe without the distortion caused by Earth's atmosphere. As we continue to plan for future missions, understanding the Moon's atmosphere or lack thereof is crucial. It shapes how we design technology, conduct research, and even think about establishing a long-term human presence. Next, we'll take a closer look at how the Moon's gravity, which is only 1/6 of Earth's, influences movement and exploration. Stay tuned as we uncover more incredible facts about our lunar neighbor. Now, turning to another fascinating aspect of the Moon, let's explore how its gravity differs from Earth's and what that means for life and exploration. The Moon's gravity is only 1/6 as strong as Earth's, which creates some truly mind-blowing effects. Imagine stepping onto the lunar surface and feeling almost weightless. Astronauts who have walked on the Moon describe it as a surreal experience, where even a small hop can send you soaring several feet into the air. This weaker gravity has some fun and practical implications. For example, if you weigh 150 pounds on Earth, you'd only weigh about 25 pounds on the Moon. That means you could carry heavy equipment with ease or leap over obstacles like a superhero. During the Apollo missions, astronauts were seen bounding across the surface, their movements almost resembling slow-motion jumps. It's not just about the fun factor, though. This reduced gravity also makes it easier to transport materials and build structures, which is a huge advantage for future lunar colonization. But the Moon's low gravity isn't all good news. Over time, it can have significant effects on the human body. Without the constant pull of Earth's gravity, muscles and bones can weaken, a challenge astronauts face even during short stays in space. To combat this, future lunar settlers might need to incorporate regular exercise routines or even artificial gravity systems to maintain their health. The Moon's gravity also plays a crucial role in shaping its environment. Because it's so weak, the Moon can't hold onto an atmosphere, which we've already discussed. This lack of atmosphere, combined with the low gravity, means that dust and debris kicked up by movement or impacts can stay suspended for much longer, creating challenges for equipment and visibility. Looking ahead, the Moon's gravity will be a key factor in planning long-term missions and potential colonization. Its weaker pull makes it easier to launch spacecraft back to Earth or to other destinations like Mars, reducing the fuel and energy needed. This could make the Moon a strategic stepping stone for deeper space exploration. As we continue to uncover the Moon's secrets, its gravity remains one of the most intriguing aspects, offering both opportunities and challenges for humanity's future in space. Next, we'll dive into another incredible discovery, the presence of water ice on the Moon and what it means for sustaining life and exploration. Stay tuned as we reveal more about our celestial neighbor. Now, shifting our focus to one of the most groundbreaking discoveries about the Moon, let's explore the presence of water ice hidden in its darkest corners. For years, scientists speculated about the possibility of water on the Moon, but it wasn't until recent missions that they confirmed its existence. Deep within the permanently shadowed craters at the Moon's poles, water ice lies trapped, shielded from the Sun's intense heat. These craters, some of the coldest places in the solar system, act as natural freezers, preserving this precious resource for potentially billions of years. The discovery of water ice on the Moon is a game-changer for space exploration. Water is essential not only for drinking but also for producing oxygen and hydrogen, which can be used as rocket fuel. Imagine a future where lunar bases harvest this ice, turning it into breathable air and fuel for spacecraft. This could drastically reduce the cost and complexity of missions, as astronauts wouldn't need to transport all their resources from Earth. Instead, they could rely on the Moon's own reserves, making it a vital stepping stone for deeper space exploration, including missions to Mars, but the implications go even further. Water is a cornerstone of life, and its presence on the Moon raises intriguing questions about the potential for sustaining human colonies. With water, we could grow plants, create habitats, and even establish long-term settlements. This discovery also opens the door to studying how water arrived on the Moon in the first place. Was it delivered by comets, or did it form through chemical reactions on the lunar surface? Understanding this could shed light on the origins of water in our solar system and beyond. Of course, extracting and utilizing this water won't be easy. The extreme conditions in these shadowed craters, with temperatures plunging to -200 degrees Celsius, pose significant challenges. Future missions will need advanced technology to mine and process the ice without contaminating it. But the potential rewards are immense, making this one of the most exciting areas of lunar research today. As we look to the future, the Moon's water ice could be the key to unlocking humanity's dreams of living and thriving beyond Earth. It's a reminder that even in the most barren landscapes, nature holds secrets that can transform our understanding of what's possible. Next, we'll delve into another fascinating feature of the Moon's surface, the dusty, rocky layer known as Regolith, and how it shapes our exploration efforts. Stay with us as we uncover more about this incredible celestial body. Now, turning to the Moon's surface, we encounter a layer that defines its rugged, otherworldly appearance, Regolith. This dusty, rocky blanket covers the Moon from pole to pole, a testament to its violent history. Over billions of years, countless meteorite impacts have shattered and pulverized the lunar surface, creating this fine, powdery material. Unlike Earth, where wind, water, and life constantly reshape the landscape, the Moon's surface has remained largely unchanged, preserving this ancient record of cosmic collisions. Regolith isn't just dust, it's a mix of fine particles, sharp fragments, and even tiny glass beads formed from the intense heat of impacts. These beads, scattered across the surface, are like tiny time capsules capturing moments of lunar history. But while Regolith tells a fascinating story, it also poses significant challenges for exploration. Its fine, abrasive texture can clog machinery, damage equipment, and even pose health risks to astronauts if inhaled. Lunar rovers and spacesuits must be specially designed to withstand this harsh environment, making every mission a delicate balancing act between discovery and durability. One of the most intriguing aspects of Regolith is its potential as a resource. Scientists are exploring ways to use it to build habitats, extract oxygen, or even create fuel. Imagine a future where lunar bases are constructed from bricks made of compressed regolith, or where astronauts extract vital resources directly from the soil beneath their feet. This could revolutionize how we approach lunar colonization, turning a seemingly barren landscape into a source of opportunity. Yet, working with regolith is no easy task. Its unpredictable composition and sharp edges make it difficult to handle, and its insulating properties can complicate temperature regulation for equipment and habitats. Despite these challenges, understanding and utilizing Regolith is key to unlocking the Moon's potential as a stepping stone for deeper space exploration. As we continue to study this ancient layer, we uncover not just the Moon's past, but also the tools to shape humanity's future among the stars. Next, we'll explore how the Moon's gravitational pull shapes one of Earth's most familiar phenomena, the tides. Stay with us as we dive into this fascinating connection between our planet and its celestial companion. Now, shifting our gaze from the Moon's surface to its gravitational influence, let's explore how our celestial neighbor shapes one of Earth's most dynamic and essential phenomena, the tides. The Moon's gravity, though weaker than Earth's, exerts a powerful pull on our planet's oceans. As the Moon orbits Earth, its gravitational force tugs on the water, creating bulges on the side of Earth facing the Moon and, surprisingly, on the opposite side as well. These bulges are what we experience as high tides, while the areas in between experience low tides. This gravitational dance isn't just a simple back and forth. The Sun also plays a role, amplifying or counteracting the Moon's pull depending on the alignment of the three bodies. When the Sun, Moon, and Earth align during a full or new moon, we experience spring tides, which are especially high and low. Conversely, when the Sun and Moon are at right angles to each other, we get neap tides, which are less extreme. This intricate interplay between the Moon and the Sun creates the rhythmic rise and fall of the oceans that we've come to rely on. But tides aren't just a fascinating scientific phenomenon. They're vital to life on Earth. Coastal ecosystems, from tidal pools to mangrove forests, depend on the regular ebb and flow of water. Many marine species, like crabs and mollusks, have evolved to synchronize their life cycles with tidal patterns. Even human activities, such as fishing and shipping, are deeply tied to the tides. Without the Moon's gravitational influence, Earth's oceans would be far less dynamic, and the delicate balance of coastal ecosystems would be disrupted. The Moon's role in shaping tides also has broader implications for Earth's climate. Tidal forces help mix ocean waters, distributing heat and nutrients across the globe. This mixing plays a crucial role in regulating Earth's temperature and supporting marine life. So, the next time you watch the waves roll in, remember that you're witnessing the Moon's invisible hand at work, a reminder of the profound connection between our planet and its celestial companion. Up next, we'll uncover a lesser-known lunar feature, the Moon's mysterious tail. Stay tuned as we dive into this intriguing phenomenon. Now, turning to a lesser-known but fascinating feature of the Moon, let's explore the fact that our lunar companion has a tail. Yes, you heard that right, the Moon has a tail, but this isn't the kind of tail you might imagine on a comet or an animal. Instead, it's a faint stream of sodium particles that extends outward into space, creating a subtle but detectable trail. This sodium tail forms as tiny amounts of sodium atoms are released from the Moon's surface, likely due to the constant bombardment of micrometeorites and the solar wind. These particles are then pushed away from the Moon by the pressure of sunlight, forming a long, wispy tail that stretches behind the Moon in its orbit around Earth. While it's invisible to the naked eye, scientists have detected this tail using specialized instruments that can observe the faint glow of sodium atoms. What makes this tail even more intriguing is how it interacts with Earth's magnetosphere, the protective magnetic field surrounding our planet. As the Moon orbits Earth, its sodium tail gets swept up by the magnetosphere, creating a temporary bridge of particles between the Moon and Earth. This interaction is a subtle but fascinating example of how celestial bodies influence one another in ways we're only beginning to understand. The discovery of the Moon's tail not only adds to our understanding of lunar science, but also highlights the intricate connections within our solar system. It's a reminder that even familiar objects like the Moon can hold surprises, waiting to be uncovered by curious minds and advanced technology. Up next, we'll take a closer look at the Moon's extreme temperatures and how they challenge both exploration and our understanding of this celestial neighbor. Stay tuned. Now, shifting our focus to the Moon's dramatic climate, let's dive into one of its most striking features, its extreme temperatures. The Moon experiences some of the most intense temperature swings in the solar system, with daytime highs soaring to a scorching 127 degrees Celsius and nighttime lows plummeting to a bone-chilling minus 173 degrees Celsius. That's a difference of 300 degrees between day and night. These wild temperature swings are a direct result of the Moon's lack of atmosphere. Unlike Earth, which has a thick blanket of air to trap heat and regulate temperatures, the Moon has no such protection. During the day, the surface bakes under the unfiltered rays of the sun, heating up rapidly. But as soon as the sun sets, all that heat escapes into space, leaving the surface to freeze in the darkness. These extreme conditions pose significant challenges for lunar exploration. Spacecraft and equipment sent to the Moon must be designed to withstand these drastic temperature changes. For example, the Apollo missions used specially insulated materials and thermal control systems to protect astronauts and instruments from the harsh environment. Even rovers and landers, like those used in more recent missions, rely on advanced technology to survive the Moon's unforgiving climate. But it's not just about survival. These temperature extremes also affect how we plan future missions. For instance, solar panels, which are crucial for powering lunar bases, must be able to function in both blistering heat and freezing cold. Similarly, any structures built on the Moon will need to be engineered to handle these conditions without cracking or failing. Understanding the Moon's temperature extremes isn't just about overcoming challenges. It's also a window into the unique nature of our celestial neighbor. These conditions remind us just how different the Moon is from Earth and highlight the ingenuity required to explore and potentially live on its surface. Next, we'll explore the Moon's origin story and the fascinating theory of how it came to be. Stay with us now, turning to one of the most captivating mysteries of our solar system, the Moon's origin story. The leading theory, known as the giant impact hypothesis, paints a dramatic picture of how our Moon came to be. Imagine, billions of years ago, a Mars-sized body, often referred to as Theia, colliding with the early Earth in a cataclysmic event. This colossal impact sent massive amounts of debris hurtling into space, where it eventually coalesced to form the Moon. This theory isn't just a wild guess, it's supported by a wealth of evidence. For instance, the Moon's composition closely matches that of Earth's mantle, suggesting they share a common origin. Additionally, computer simulations of such an impact align perfectly with what we know about the Moon's formation and its current orbit. But why does this matter? Understanding the Moon's origin isn't just about solving a cosmic puzzle, it's about piecing together the history of our own planet. The collision that formed the Moon also played a crucial role in shaping Earth's early environment, influencing everything from the length of our days to the stability of our climate. This theory also highlights the dynamic and often violent nature of the early solar system, where massive collisions were not uncommon. It's a reminder of how interconnected the celestial bodies in our solar system truly are. Next, we'll uncover another fascinating aspect of the Moon, its potential as a source of clean energy. Stay tuned now, shifting our gaze to a resource that could revolutionize energy production here on Earth, helium-3. This rare isotope, found in abundance on the Moon, has sparked excitement among scientists and futurists alike. Unlike the helium we use to fill balloons, helium-3 is a lightweight, non-radioactive isotope that could be a game-changer for clean energy. When used in nuclear fusion reactors, it has the potential to produce vast amounts of energy without the harmful radioactive waste associated with traditional nuclear power. So, why is the Moon such a treasure trove for helium-3? over billions of years, the Moon's surface has been bombarded by solar winds which carry particles like helium-3. Because the Moon lacks an atmosphere, these particles have accumulated in its regolith, or surface layer. Estimates suggest there could be up to 1 million metric tons of helium-3 embedded in the lunar soil, enough to power Earth for thousands of years if harnessed effectively. The implications of mining helium-3 on the Moon are staggering. Not only could it provide a nearly limitless source of clean energy, but it could also pave the way for sustainable lunar colonization. Imagine a future where lunar bases extract helium-3 to fuel both their operations and energy needs back on Earth. This could reduce our reliance on fossil fuels and help combat climate change. However, the challenges are significant. Extracting helium-3 would require advanced mining technology and infrastructure on the Moon, not to mention the development of efficient fusion reactors. Despite these hurdles, countries and private companies are already exploring the possibilities, with some even proposing lunar missions specifically aimed at helium-3 extraction. As we look to the stars for solutions to Earth's energy crisis, helium-3 stands out as a beacon of hope. Its potential to transform our energy landscape is immense, and the Moon, our closest celestial neighbor, holds the key. Next, we'll explore how the Moon's unique rotation keeps one side forever hidden from our view. Stay with us now, turning to one of the Moon's most fascinating quirks, its synchronous rotation. This phenomenon, also known as tidal locking, is the reason we only ever see one side of the Moon from Earth. But what exactly does that mean? Let's break it down. The Moon takes roughly the same amount of time to rotate on its axis as it does to orbit Earth, about 27 days. This perfect synchronization means that the same side of the Moon always faces us, while the other side remains hidden. It's like a cosmic dance where the Moon spins just enough to keep one face turned toward its partner, Earth. This tidal locking didn't happen overnight. Over billions of years, Earth's gravitational pull gradually slowed the Moon's rotation until it matched its orbital period. Think of it as a gentle tug of war where Earth's gravity won out, locking the Moon into this unique rhythm. The effects of this synchronous rotation are profound. For one, it means that the far side of the Moon, often mistakenly called the dark side, is never visible from Earth. But don't let the name fool you, it's not always dark. The far side receives just as much sunlight as the near side. It's simply always turned away from us. This hidden side remained a mystery until the Soviet Union's Lunar 3 spacecraft captured the first images of it in 1959. Since then, missions like NAS, a lunar reconnaissance orbiter, have provided detailed maps, revealing a landscape dotted with craters and fewer of the smooth, dark plains or maria that we see on the near side. Tidal locking also has implications for future lunar exploration. For example, communication with rovers or bases on the far side would require relay satellites, as direct signals from Earth would be blocked by the Moon itself. So the next time you gaze up at the Moon, remember that its familiar face is just one half of a much larger story. The other side, hidden from view, holds secrets waiting to be uncovered. And as we continue to explore, who knows what discoveries await us in the shadows of our celestial neighbor. Next, we'll dive into how the Moon's craters serve as a time capsule, preserving the history of our solar system. Stay tuned. Now, shifting our focus to the Moon's surface, we uncover a story written in scars. Its countless craters. These craters are more than just pockmarks. They're a record of ancient cosmic collisions that have shaped not only the Moon but also our understanding of the solar system's history. Each crater tells a tale of a violent impact, some dating back billions of years. Unlike Earth, where weathering and tectonic activity erase such marks over time, the Moon's surface remains largely unchanged. This makes it a pristine archive of the solar system's past. By studying these craters, scientists can piece together a timeline of when and how often objects like asteroids and comets have struck the Moon, and by extension, Earth. One of the most fascinating aspects of these craters is their size and depth. Some, like the South Pole Aitken Basin, stretch over 2,000 kilometers wide and plunge several kilometers deep. These massive impacts reveal the sheer force of the collisions that once rocked the early solar system. But it's not just about size. The distribution of craters across the Moon's surface also provides clues. For instance, the far side of the Moon, which we discussed earlier, is far more heavily cratered than the near side. This suggests that the near side was resurfaced by ancient volcanic activity, creating the smoother plains we see today. Studying these craters isn't just about looking back in time, it's also about preparing for the future. By understanding the frequency and scale of past impacts, scientists can better predict the likelihood of future collisions with Earth. This knowledge is crucial for developing strategies to protect our planet from potentially catastrophic events. So, the next time you look at the Moon's surface, remember that those craters are more than just marks. They're a window into the solar system's turbulent past and a guide for safeguarding our future. As we continue our journey, we'll explore how the Moon's gravitational pull is subtly changing Earth's rotation, shaping our planet in ways you might not expect. Stay tuned. Now, turning to the Moon's subtle yet profound influence on our planet, let's explore how its gravitational pull is quietly reshaping Earth's rotation. While it might seem like the Moon is just a distant companion, its gravitational tug is actually slowing down Earth's spin over time. This phenomenon, known as tidal braking, occurs because the Moon's gravity creates friction between Earth's oceans and its solid surface, gradually sapping energy from our planet's rotation. The result, Earth's days are getting longer, but don't worry, it's happening at an almost imperceptible rate. Scientists estimate that the length of a day increases by about 1.7 milliseconds every century. That might not sound like much, but over millions of years it adds up. For example, during the age of the dinosaurs, a day on Earth was only about 23 hours long. This slowing rotation has far-reaching consequences. As Earth's spin decreases, the Moon moves slightly farther away from us, a process we touched on earlier. But the effects don't stop there. A slower rotation can influence Earth's climate by altering atmospheric circulation patterns and ocean currents. Over geological timescales, these changes could contribute to shifts in weather systems and even impact the distribution of life on our planet. Interestingly, this relationship between Earth and the Moon is a two-way street. Just as the Moon affects Earth's rotation, Earth's gravity has shaped the Moon's history, locking it into synchronous rotation and creating the tidal forces that cause moonquakes. It's a cosmic dance that has been ongoing for billions of years, and one that continues to shape both worlds in ways we're only beginning to fully understand. So the next time you glance at the Moon, remember that its influence extends far beyond the tides. It's a silent partner in Earth's journey through time, subtly shaping our days, our climate, and even our future. As we move forward, we'll uncover another fascinating aspect of the Moon, its mysterious magnetic fields, which hold secrets about its geological past and potential for future exploration. Stay tuned. Now, shifting our gaze to another intriguing aspect of the Moon, let's explore its mysterious magnetic fields. While the Moon doesn't have a global magnetic field like Earth, certain regions on its surface do exhibit localized magnetic activity. These magnetic anomalies, often referred to as lunar swirls, are areas where the Moon's surface appears brighter and more reflective, and they're accompanied by surprisingly strong magnetic fields. So, how did these magnetic fields form? Scientists believe they're remnants of the Moon's ancient past. One leading theory suggests that billions of years ago, when the Moon was still geologically active, massive asteroid impacts may have generated intense heat and pressure, temporarily creating molten regions in the lunar crust. As these areas cooled, the minerals within them could have aligned with the Moon's weak magnetic field at the time, preserving a magnetic signature that persists to this day. These localized fields aren't just a curiosity, they hold important clues about the Moon's geological history. By studying them, researchers can piece together how the Moon's interior evolved and how its magnetic environment has changed over time. This information could also shed light on the early history of our solar system, as the Moon's magnetic record may reflect conditions that existed during its formation. But the implications don't stop there. These magnetic fields could play a crucial role in future lunar exploration. For one, they might help shield astronauts and equipment from harmful solar radiation, which is a significant challenge for long-term missions on the Moon. Additionally, understanding these magnetic anomalies could guide the selection of landing sites for future missions, ensuring safer and more scientifically valuable exploration. As we continue to unravel the Moon's secrets, its magnetic fields remind us that even a seemingly barren world holds layers of complexity waiting to be discovered. And with that, we'll turn our attention to another fascinating feature, the Moon's size compared to Earth, and how this unique relationship shapes its influence on our planet. Stay with us now. Turning to the Moon's size, let's put things into perspective. The Moon is about 1/4 the diameter of Earth, making it the 5th largest natural satellite in our solar system relative to its parent planet. To give you a clearer picture, if Earth were the size of a basketball, the Moon would be roughly the size of a tennis ball. This might not sound enormous, but compared to other moons in our solar system, our Moon is unusually large in relation to its planet. This unique size difference plays a significant role in the Moon's gravitational influence on Earth. Despite being much smaller, the Moon's gravitational pull is strong enough to create the tides we experience in our oceans. This is because gravity isn't just about size, it's also about distance. The Moon is relatively close to Earth, orbiting at an average distance of about 384,000 kilometers. This proximity, combined with its substantial size, allows it to exert a noticeable gravitational force on our planet. But the Moon's influence doesn't stop at the tides. Its gravitational pull also affects Earth's rotation. Over billions of years, the Moon has been slowing down Earth's spin, gradually lengthening our days. In fact, when the Moon first formed, an Earth day was only about 5 hours long. Today, thanks to the Moon's gravitational tug, a day lasts 24 hours. This ongoing interaction between Earth and the Moon is a delicate dance, one that has shaped the rhythm of life on our planet. Interestingly, the Moon's size also makes it a key player in stabilizing Earth's axial tilt. Without the Moon, Earth's tilt could vary dramatically over time, leading to extreme and unpredictable climate changes. The Moon's gravitational influence helps keep our planet's tilt relatively steady, creating the stable seasons that have allowed life to thrive. So, while the Moon may seem small compared to Earth, its size and proximity give it an outsized impact on our planet. From shaping our tides to stabilizing our climate, the Moon's presence is a testament to how even a seemingly modest celestial body can have profound effects on the world we call home. And with that, let's dive into the next fascinating fact: how the Moon plays a starring role in creating eclipses, one of nature's most awe-inspiring spectacles. Stay tuned. Now, shifting our gaze to the skies, let's explore one of the Moon's most dramatic performances: its role in creating eclipses. These celestial events where the Sun, Earth, and Moon align in perfect harmony are nothing short of breathtaking. But how exactly do they happen? Let's break it down. A solar eclipse occurs when the Moon passes directly between the Earth and the Sun, casting a shadow on our planet. For a brief moment, the Moon blocks the Sun's light, turning day into an eerie twilight. This can only happen during a new moon phase, when the Moon is positioned between the Earth and the Sun. The alignment has to be nearly perfect, which is why solar eclipses are relatively rare and often visible only from specific regions on Earth. On the other hand, a lunar eclipse takes place when the Earth comes between the Sun and the Moon, casting its shadow onto the lunar surface. This happens during a full moon phase when the moon is on the opposite side of the Earth from the sun. As the Earth's shadow creeps across the moon, it can turn a deep red or copper color, earning it the nickname blood moon. Unlike solar eclipses, lunar eclipses are visible from anywhere on the night side of the Earth, making them more accessible to observers. The key to both types of eclipses lies in the moon's orbit. The moon's path around the Earth is tilted slightly compared to Earth's orbit around the sun. This means that most of the time, the moon passes above or below the sun from our perspective, avoiding an eclipse. But when the orbits align just right, the moon's position creates these stunning celestial events. Eclipses have fascinated humans for millennia, inspiring myths, legends, and scientific discoveries. Today, they serve as a reminder of the intricate dance between the sun, earth, and moon, a dance that continues to shape our understanding of the cosmos. And with that, let's move on to the next fascinating fact, where we'll uncover the moon's potential as a stepping stone for humanity's future in space. Stay tuned. Now, as we look toward the future, the moon emerges not just as a celestial neighbor, but as a potential home for humanity. The moon's potential for colonization has captured the imagination of scientists, engineers, and dreamers alike, offering a stepping stone for deeper space exploration. But what makes the moon such a promising candidate for human settlement? Let's dive in. One of the most compelling reasons for lunar colonization is its proximity to Earth. At just about 384,000 kilometers away, the moon is close enough to allow for relatively quick travel compared to other destinations in our solar system. This makes it an ideal testing ground for technologies and systems that could one day support missions to Mars and beyond. Plans for lunar bases are already in motion, with space agencies and private companies envisioning habitats that could sustain human life. These bases would likely be built in regions near the moon's poles where sunlight is nearly constant, providing a reliable energy source for solar power. Additionally, the permanently shadowed craters in these areas are believed to contain water ice, a critical resource for drinking, growing food, and even producing rocket fuel. Resource utilization is another key factor in the moon's colonization potential. The lunar surface is rich in materials like helium-3, a rare isotope that could revolutionize clean energy production on Earth. Mining these resources could not only support lunar colonies but also fuel further space exploration, reducing the need to transport materials from Earth. The moon also serves as a natural laboratory for studying the effects of long-term space habitation. Its lower gravity, about 1/6 of Earth's, provides a unique environment to test how humans and equipment adapt to extended periods in space. These insights will be invaluable for planning missions to Mars, where astronauts will face similar challenges. Moreover, the moon's role as a staging point for Mars missions cannot be overstated. Establishing a lunar base could act as a refueling station, reducing the cost and complexity of launching missions directly from Earth. It could also serve as a training ground for astronauts, allowing them to practice living and working in a harsh, alien environment before venturing further into the cosmos. As we dream of a future where humanity becomes a multi-planetary species, the moon stands as a critical first step. Its colonization could unlock new frontiers in science, technology, and exploration, paving the way for humanity's journey to the stars. And with that, let's turn our attention to the moon's enduring influence on human culture, a story that spans millennia and continues to inspire us today. Now, as we shift our gaze from the moon's scientific marvels to its profound impact on human culture, we uncover a story that has captivated humanity for thousands of years. The moon has not only been a celestial body in our skies, but also a muse, a symbol, and a source of endless inspiration across civilizations. From ancient myths to modern masterpieces, the moon has woven itself into the fabric of human storytelling. In Greek mythology, the moon was personified as Selene, a goddess who rode her silver chariot across the night sky. In Chinese folklore, the moon is home to Chang, the immortal goddess who resides in a lunar palace accompanied by a jade rabbit. These stories reflect the moon's universal presence in our collective imagination, transcending borders and eras. The moon has also played a pivotal role in shaping art and literature. Poets like William Wordsworth and Emily Dickinson have immortalized its beauty in verse, while painters such as Vincent van Gogh captured its ethereal glow in masterpieces like Starry Night. The moon's enigmatic presence has inspired countless works, from Shakespeare's romantic sonnets to the haunting melodies of Debussy's Clair de Lune. Beyond art, the moon has influenced cultural practices and traditions. Lunar calendars based on the moon's phases have guided agricultural cycles and religious festivals for centuries. The Mid-Autumn Festival in East Asia, for example, celebrates the moon's fullness with mooncakes and lanterns, symbolizing unity and gratitude. Similarly, the Islamic calendar relies on lunar cycles to determine significant events like Ramadan. In modern times, the moon continues to inspire innovation and creativity. It has become a symbol of exploration and ambition, epitomized by the Apollo missions that first brought humans to its surface. The iconic image of Earthrise captured from lunar orbit reshaped our perspective on our planet and our place in the universe. Today, the moon remains a beacon of hope and possibility, fueling dreams of interstellar travel and the search for life beyond Earth. As we reflect on the moon's cultural significance, it's clear that its influence extends far beyond its physical presence. It has been a mirror for our dreams, fears, and aspirations, reminding us of the boundless potential of human imagination. And with that, we conclude our journey through 20 mind-blowing facts about the moon, each one revealing a new layer of its mystery and wonder. If you enjoyed this exploration, don't forget to like, subscribe, and hit the notification bell for more fascinating insights into the universe. Share your favorite fact about the moon in the comments below, and let's keep the conversation going. Until next time, keep looking up. Now, as we bring our lunar journey to a close, let's take a moment to reflect on the incredible insights we've uncovered. From the moon's slow drift away from Earth to its hidden water ice reserves, each of these 20 mind-blowing facts has revealed a new layer of its complexity and significance. We've explored how the moon shapes our tides, influences our planet's rotation, and even holds the potential to power future technologies with helium-3. Its surface, marked by ancient craters and moonquakes, tells a story billions of years in the making, while its cultural impact spans myths, art, and traditions across the globe. The moon is more than just a celestial neighbor. It's a testament to the wonders of our universe and humanity's enduring curiosity. Whether it's the mystery of its dark side, the science behind its synchronous rotation, or its role as a stepping stone for space exploration, the moon continues to inspire and challenge us. So, what's your favorite fact about the moon? Was it the discovery of water ice that could sustain future missions, or the awe-inspiring image of Earthrise that changed how we see our planet? Share your thoughts in the comments below, and let's keep the conversation alive. If you enjoyed this cosmic adventure, don't forget to like, subscribe, and hit the notification bell for more fascinating explorations of the universe. Until next time, keep your eyes on the skies and your curiosity alive.